Yeah. So now here, what is Terraform? The Terraform is the leader in IaC. IaC stands for Infrastructure as a Code. The main advantage is with the pipeline, like with the CI/CD pipeline, programmatically reusable kind of scripts we need to use. That's what like one of the industry standard as of now to provision the infrastructure. Say previously we used to provision the infrastructure very manually, but that's not the best process. Like today we need to provision the infrastructure through automation itself. Among the Terraform is the leader. Okay, so now here one question what people will ask from the DevOps wise is IaC versus configuration management. Okay, so what is the difference between IaC and the configuration management? Can you tell me? What is the difference between IaC and what is the difference between configuration management? And which one comes into the first IaC will come or configuration management will come in the DevOps process? Please explain me what is IaC and what is configuration management. So what is the difference between IaC and configuration management? IaC is the infrastructure, like maybe it's AWS resources or on-premises resources. Those all we are provisioning. What is the meaning of configuration management in the DevOps? So what is the meaning of configuration management? Okay, so now infrastructure can be provisioned through IaC, whereas in the configuration management, so we are going to configure those missions. Either this may be IT automation mostly can be done. Say even IaC also is an IT automation itself, but it's more the configuration management we are going to perform. Like maybe once we got the hardware. Or once we got the instance, okay, so assume in AWS we got the instance, that instance backend it required maybe networking, monitoring, IAM roles, all these we are provisioning through IaC itself. Okay, then that's VPC related or EBS, S3, CloudWatch, auto scaling, all these resources creation comes under, all this resource creation comes under IaC.
IaC.
IaC. On top of this, what configuration management will do? What
So
configuration management will do?
it will automate.
Yeah, it will automate. Say, suppose I got assume 100 servers I got in the Terraform. Those 100 servers, I want to like install patching kind of activities. Okay, so patching, say at the OS level or kernel level, application level, or maybe virus, antivirus kind of level, we want the patching need to be done. So that patching comes under IaC or configuration management. Updates or maybe like we can call that patches, updates, all this comes under configuration management. Then software distribution, can you tell me some examples of software distributions? Say I want to install Nginx, Tomcat, WebSphere, WebLogic, Tomcat, okay, HA proxy, RabbitMQ, message queues, all these installation is called as,
Software distribution.
okay, software like distribution or software installations, those also comes under IaC or configuration management.
Config management.
Configuration management. After this, I want to manage the services. Say I want to start the service, stop the service, restart the service. Say these all we have done. Like for one or two servers, if I have the hundreds of servers that can be automated by using,
Configuration
that can be
management.
automated by the configuration management kind of tool. You may get it out. So why I need to go for configuration management tool? If it is one mission, we can do. But one of the feature of DevOps is DevOps can do at the high scalable level. If the same scenario you need to do it by 100 servers 100 times, that's very time consuming and very expensive kind of thing. Means the return on investment on the automation comes by reusing that script. If I have developed the automation script and if I don't get much reusability, then what is the investment I have done? It's a waste of money for us. I hope you got it right.
Yeah.
So then here, even more than this, not only the services, maybe restart kind of things, or reload kind of things, or shutdown kind of things also we can do through like configuration management itself, user management, okay, groups, okay. So whatever we can do on the Linux level, all those comes under configuration management. So all these we are going to perform through the configuration management we are going to perform. Okay, then the first step is IaC. After that, we are going to perform the configuration management. Okay, for IaC we have the solutions like Terraform, or we have Cloud Formation, ARM templates, Biceps, like this we have. For the configuration management, say we have the leader is Ansible is the leader. Then Puppet is there, or Chef is there. So these are the three players we have in the market. Among these, Ansible is the leader. In the configuration management, going forward, we'll discuss Ansible. Say in the interview, either people can ask us the IaC versus configuration
Configuration.
management, or people will ask us Ansible versus Terraform. Almost it's the same. Okay. IaC, say suppose CloudFormation versus Terraform is different use case. Both are IaC solutions only. Okay, but here Ansible versus Terraform is
Configuration
different use
versus
case.
IaC.
Okay. So then, say now here what Terraform will do. Terraform is one of the leader in IaC, supports more than 1,000+ providers, and those 1,000 providers has been developed by Terraform. Okay, say using like Go language. What is the meaning of Terraform is what is that meaning of providers are all the resources and data sources, we are getting a documented one, and we can use the simple declarative scripts, okay, by using that providers. So who is developing the providers here is Terraform is providing. Now we have a Terraform, then we are going to use the HCL kind of scripts. Okay, say HCL using is an advantage or disadvantage compared to JSON or YAML. Again, it's a small drawback itself, because nowadays most of the tools are supporting YAML or JSON itself, but Terraform having their own domain specific language. What is that? HCL, HashiCorp configuration language. That's a small disadvantage compared to the new tools like CloudFormation or ARM templates. Okay, but say HCL is a simple human readable declarative updates we have, and we are going to use the providers. Then that's going to use with the AWS SDK or APIs. Okay, so now when that provider is getting downloaded for us is say in our main dot, say suppose here we are going to create one directory. In that directory we are going to keep all TF files. In the TF files we are going to keep the which provider we are going to use. Then when we do the Terraform init, okay, that's directory is becoming our Terraform workspace. Okay, so don't get confused with the workspace concept. Terraform workspace is different, but that means as of now we are working only with the one workspace. But in the real time, we may need to work with the multiple workspaces also. One use case is my dev environment is different, QA environment is different, production is different. Then I'm going to create the different workspaces. So Terraform, we are going to use the different workspaces we are going to use. Then whenever we do the Terraform init, a workspace is getting initialized. A Terraform workspace is getting initialized. That directory will become the workspace, and the scope of all the files also in that directory or that workspace we are going to use. And going forward, we can work with the multiple workspaces also. Okay, so then whenever we do the Terraform init, two files, like some not files, one directory is getting created, that is .terraform. In this, whatever the provider we have given in our main.tf or provider.tf, that is going to download from Terraform dot sorry, not Terraform, from the Terraform registry is getting downloaded. That means it's required the internet access. Then Terraform registry is going to download. Then we are going to get one more hidden file, that is Terraform dot log dot HCL file is also is getting generated. These two files are getting created when we do the Terraform init, and that provider, which provider it need to download, because there are some hundreds of or thousands of providers. How Terraform knows which provider it need to take? Can you tell me?
Because we
Have a
specify the required providers.
come again?
We specify required providers
Yeah, where we are specifying
in main.tf or
in the
any other
main.tf or
file.
provider.tf, which version you want, all these we need to specify. Then from where it is getting downloaded, from the Terraform registry, to which directory, .terraform directory it is getting downloaded, and it's a by default it's a hidden directory. And the .terraform.log.hcl will specify, even if any newer version of provider is available, I don't want to use that newer version because I may have a compatibility issues. Then we are locking till I update my like a Terraform version, like this provider itself it need to use. Even if any newer version is available also, terraform.log.hcl will specifying exactly this provider version it need to use, because if I upgrade to the higher version, my resources, my configuration files may have backward compatibility issues. Okay. Then here all the extensions of those are .tf files we have. Okay, then from these tf files, can you tell me some of the important tf files we can have? Main.tf, actually we are going to store all the resources. Then provider.tf we can use, or terraform.tf, then backend.tf. Okay, then variables.tf, inputs.tf, sorry, inputs is nothing but variables. Outputs dot
TF.
tf. Okay, so even we can maintain the versions dot tf. Why we'll use versions dot tf also? We'll discuss. So these all the files we are going to create. Okay, so then from this, when we do the Terraform, we can do Terraform validate. Say validate will perform any logical related issues. All those is going to validate. Then we can use even alignment kind of things. All those
Update
format we can use. Then very, very important thing, Terraform
plan.
plan. So what Terraform plan will do is, Terraform plan shows the blueprint of whatever the resources are getting created. That's we are going to store in the Terraform plan. Say all the resources we are going to display, it shows the blueprint of the resources. Okay, say someone ask about the plan means, it's make a practice of using the word called it's a blueprint. Okay, so then in the Terraform plan we are going to store the blueprint of the resources. Then when like it's not going to create the resources, it shows only these preview of the resources it is showing. Either blueprint we can call, or a preview we can call. And even we can save that as an output file also, and that we can send to a reference purpose. Okay, so when you are constructing a house, you will get a house plan or not? So in the
Yes.
house plan itself we can identify a lot of issues, right? Because that is in the plan itself, it's a paper kind of thing. But in the final output, if you have any errors, it's we need to demolish our house, or need to invest 5 to 10 lakhs of like maybe alteration kind of work, or even it's anything is in the lakhs itself. But here it's only in the like hundreds or thousands itself, because it's in the planning stage itself. Okay, so then Terraform plan shows the blueprint or preview of the resources, and is one of the best practice. Always use the plan. Don't directly goes to
Apply.
apply. Then what apply will do?
Apply will create the resources.
Apply will create the actual resources. Okay, apply will create the actual resources. So now here we are going to use Terraform apply. The actual resources are getting created in that like provider what we have specified. That's maybe AWS, Azure, or Kubernetes, Docker. Okay, so I am telling right there are more than 1,000 providers: OCI, GCP, Ali Cloud, VMware, whatever it may be. Then what exactly the meaning of Terraform apply? Sorry, one file is getting created when we do the Terraform apply. That file is called as okay, say state file. The name of the state file in the local environment is creating. That means in the local workspace, that state file by default if you create, but we have some challenges with that. But the name of the state file is terraform.tf state. So terraform.tf state is the state file name. Okay, so once we call that state file, okay, it's automatically creating or we are creating it manually?
Wait, it is automatic. This is
It's
automatically created.
automatically is getting created and in which format it is going to store.
JSON format.
Yeah, it's in the JSON format it is going to store that, not HCL. It's a JSON format that details are getting stored, that output values, all those are stored. Okay, in order to read that, we can use Terraform state show something command is there, or show also we can use. Okay, so now, like whenever we do the changes in the state file, then automatically that state file will become terraform.tf state.backup, and the new changes will comes into terraform.tf state file. Okay, that backup file, what is the advantage is if the existing state file has been tampered or corrupted, at least we'll have that backup file would be there. That backup file would be there. That is the purpose we are going to use. That is the purpose we are going to use the backup file. It's also automatically creating whenever the changes are going to perform on the state file. That existing state file is going to become the backup file, and the new changes will comes into the new state file. Okay. So then once we got the state file, then here we are going to get the all the resources. Now here we need to map, say state file is nothing but the mapping of the resources, the mapping of the resources. Okay, so now here if you come to the state file, okay, what state file is do is like the current status of the infrastructure is managed by Terraform wise from the state file. If you don't have the state file is there, what is the problem is each and every time the duplicate kind of resources are getting created. Okay, have seen one ad, Ramesh Suresh. So they keep on forgetting and they're like they will do again the same task, right? Okay,
Five-star chocolate advertisement,
yeah,
sir.
so that's it. Okay, so in the same way, if the Terraform doesn't have the state file, each and every time it will create the duplicate resource. Okay, so hence definitely we need the mapping of that that's going to be tracked from the Terraform wise. That state file itself is the reference. Okay, the Terraform itself is the, say it's going to track the infrastructure state. Okay, then it's enable the updates or modifications if anything performed through Terraform. All those changes also will comes into that state file, and resource dependencies. All this also is going to stay and in that remote backend enabled. It's going to be collaboration also is going to provide, and if any changes has been performed manually, even it can be done as the drift detection kind of thing. So what is the meaning of drift is the state file is having one thing and that resource is another state. That state is called as drifted. So assume I'll tell one example. In my Terraform, I have open only 22 and 80 ports. Okay, but I manually open SSH also, sorry, HTTPS also 443 I opened. But what Terraform is assuming in that resource only 80 and 22, but actual that resource is one more port is also is open, 443 is also is open. That kind of state is not at all recommended in the Terraform wise, and that's called as drift. So what is the meaning of drift here? If any of the resource has been okay, modified without knowing to the Terraform, that's called as the drift. And even we'll have the hundreds of resources. If any of the resources are in the drifted state, we need to bring to actual state. Okay. So then if we don't have the state file, we are going to lose the infrastructure tracking. Again, it lead for duplicate kind of resources. Okay. So it lead for duplicate kind of resources. I'll tell one example, try to understand. Here we have three things. One is main.tf. Second one is terraform.tf state. Third one is actual resources. In our example, I may be calling as EC2. But it's not mandatory EC2 itself. That's maybe 1500 resources what AWS may support. Okay. Then that specifications all are stored in. All that specifications have been stored in
Main.tf.
main.tf. And that outputs of those values, all the meta values are stored in
TF state.
TF state. Actual resource is existing in AWS in our scenario. Now, what I'm going to do is, now all are in the sync itself. All are in sync. Then we don't have any problem. Now, some resource has been done manual modification. That means that resource has been modified through GUI or command line. That status is called as
Drift.
drift. Then if that state is required for you, then you can bring to that we need that change. Then you can bring that to your state file by running the command. Can you tell me what is the command to bring that change into our state file? We can run one command.
Terraform refresh.
Yeah, perfect. Terraform refresh will bring that change into local state file. Okay. So then, like here, we'll use one more use case. Then again, refresh. What it will do is this will sync here, but it is missing on
Main.tf.
in the main.tf. Okay. So now try to understand. It's missing on main.tf. Then if I do Terraform apply, what is going to happen? If I do the Terraform apply, what is going to happen?
I think new.
Okay, if I
provision
do
the
the
old
Terraform
resources
apply,
and
then it will update the state file and actual resource as per main.tf. Okay, whenever we do the Terraform apply, okay, that configuration file, that main.tf or all those TF files are there, right? Those will have the higher precedence. Those will have the higher precedence. Okay, so then all comes into sync itself, but the changes are coming from the main.tf, but actual resource I want, which are the changes done by manually, then update your main.tf also as per the configuration changes. That is the reverse order. You got it right? Because all the people may not aware about the Terraform in the job. Some developers or some QA teams may have done those manually. Then again, we need to bring that same state. But if you do the Terraform apply, what is going to happen? It gets the again that our configuration change, but the client or dev or like QA team doesn't want that. That's the reason in the reverse order also you need to update your state file. Those changes you are bringing to state file through Terraform refresh and manually perform those changes in your main.tf file also. Okay, now I'll tell one use case. Try to understand. Here all are sync. The three syncs you can understand, right? Now what happened is someone deleted that instance. Normally, if you want to delete that instance, you need to use Terraform destroy. Terraform destroy will remove it from the state file also, and even from that actual resource also is getting deleted. But without knowing to these all the things, someone deleted the instance. Then what is going to happen? If I do Terraform refresh also, it can't do anything because that instance itself is not there. Okay, then I want to say anyhow that resource I don't want. Okay, then what I need to do is so now here Terraform
Target.
come again.
Target.
We need to use the command terraform show,
Okay.
and with that details we need to create the resource in main TF.
No. First we need to delete it from the state file also, right?
So then we can use the
Yeah.
underscore
Okay.
Suppose
target.
one method is from the state file we can do. Again, we need to perform
It's for restoring.
Terraform plan and apply. If you want to remove it from the state file, what we need to do? If you want to remove it from the state file, what we need to do is Terraform state rm, that is the command.
We will delete it from main.tf. After that we apply.
It's not deleted from the main.tf. That actual resource got deleted.
Yes, we need to delete in main.tf also.
Yes. From the state, I'm deleting from state rm. Okay. Then I'm deleting it from say
Main.tf.
whatever like
Main.tf.
Somesh telling also is a good thing. Directly we can keep in the main.tf. Then when we do the apply, that resource is getting deleted. Then that should be removed even from the
State file.
state file. Otherwise, we can use Terraform state rm. Okay. Then remove it from the main.tf file also. Okay. So then say one scenario I'm doing here. That resource got deleted. I didn't delete it from main.tf and even state file also. If I do Terraform apply, what is going to happen? Can you tell me in this use case? That resource manually got deleted. Then what is going to happen?
I think might be it is deleted automatically.
Come again?
Might be it will be deleted automatically by state file or manual file. That
No, that is wrong. If I do Terraform apply in this use case, what is going to happen? That resource is only deleted from manually. So that resource is existing in state file or not?
Yes.
Yes. Then what main.tf will assume?
No configuration changes required. Something.
No configuration changes are required. But as of now, in the newer versions, Terraform plan will recognize that resource is not existing kind of thing. But here, as of now, like a state file and main.tf is sync or not.
Yeah.
But that actual resource is not
Available.
this is the
Existed.
drifted state only, right?
Hmm.
Okay. Then again, you need to delete it from the main.tf. Or if you delete it from the state file, what is going to happen? In which use case you will remove that from the state file? Can you tell me one example or one scenario? That deleted out manually, but still I want that resource. Okay, then what I will do is I'll remove it from the
State file.
state file. Then
And
again I will do
apply.
the Terraform plan and apply. Then what is going to happen?
A resource
it
will be
will be
created.
That resource is getting created again. That resource is getting.
Created.
I hope you got it right.
Yeah.
Any doubts on this? Okay, so then I have my main.tf, all are in sync. I have performed Terraform state rm command. then what is going to happen? Again, this is the worst use case. Because we are doing the mistake, right? State RM unnecessarily we shouldn't do. Now, if I do Terraform apply, what is going to happen?
One more resource will be created.
One more, it's a duplicate resource.
Duplicate.
Okay, so these kind of mistakes we shouldn't do. Okay, so if that resource without deleting, we shouldn't only delete in the state file. Okay. So these all the mappings, dependencies, all those are getting stored in the state file. Okay. Now, by default, the name of the state file is terraform.tf state, and locally we have that terraform.tf state in our local workspace. We have our local directory we have. But what is the problem with this is in the collaborative environment where we have the multiple persons are going to use the Terraform. Everyone making a local version of the state file is not a not a best practice. Other changes we are missing. That's the reason we need a shared kind of state file we need to maintain. Then we have a remote backend is the concept. Say for the remote backend, we have the different solutions in AWS. We are using AWS S3 buckets we are using. Our Terraform itself is providing Terraform Cloud, or we can use even Azure wise also we can use blob storage. Okay, or we can use GCP also, like Google Storage also we can we can use. Okay, so now here we are going to use any of these persistent volumes, all those also we are going to use. Okay, so then like in this use case, what is going to happen is like another problem we are getting is if the multiple people try to perform the resources or provisioning at the same time, again the state file is going to be tampered or corrupted. That's the reason we need to enable locking. Okay, now by default in the S3, we don't get the locking by default. That is the reason with the S3 plus DynamoDB, okay, say we are giving the locking. But if you use the Terraform Cloud, Azure Blob Storage, you no need to go for explicitly DynamoDB kind of thing. By default, that storage itself is giving the locking feature also. Can you tell me the advantage of having the locking? What is the
Nobody
advantage of
will have an
locking?
access so to override it.
Yeah, so suppose if the multiple people perform at the same time, it's going to be tampered the state file. In order to avoid that one, we are going to use
Locking.
locking we are going to use. Okay, so then for the AWS S3, we are going to use the DynamoDB table we need to specify. Okay, sure. Any doubts on this? So in the real time, it's mandatory we need to enable remote backend. For Monday, I'm giving this assignment. Okay, so everyone try to keep either Terraform Cloud or AWS S3 or Azure. Okay, GCP, anything we need to choose. And one question I'm asking, we can use both AWS and Azure, right? Then for each one, is it possible to keep two state files? Okay, you need to confirm me. And for AWS resources, I want to use AWS state file. For Azure resources, I want to use.
Azure
Is it
state.
possible or not? You need to confirm me. But not a best practice. But whether it's feasible or not, you need to confirm. Okay. Yeah. Any doubts on this? So definitely we need to keep the state file like in the remote backend itself. Okay. And that is the reason we are going to use one TF file. What is the name of the TF file? Backend dot TF file we are going to keep. Backend dot TF file. Okay. So then Here coming to again coming back to this Terraform wise. So now here we need to understand Terraform providers. In the providers we have the resource blocks and the data
Data.
source blocks. Okay, so that resource is going to create a new resource in that provider, and data source is already out of our Terraform. Some resources are there, but I want to reuse them. Then we need to declare as data source. Why we can't declare as the resources is those are not in our scope. Those are the other Terraform managed resources are out of our Terraform that may be managed through GUI or whatever it may be, but we don't want to manage. Now here the resource and data source we need to understand. Then here we have three commands. Try to understand. We have refresh, import, then data. Data source is nothing but data is the keyword. So can you tell me the use cases in which case you are going to use the refresh, which case you are going to use the import, and which case you are going to use data? Can you explain me that?
Refresh for whenever drift scenario,
Yeah, drift that resource is existing in the state file.
but not in the actual resource.
Yeah, that resource, the state file is going to change, but where it is missing, those changes not coming directly to
State file.
into the state file.
And
Okay.
the
Then
data will be
what is the use case for import?
um, uh, import.
Yeah. Say all these days, okay, all these days what we have done is we have created through GUI, through the AWS management console, we created those resources. Now we got the maturity of Terraform is required. Then those resources we need to create now onwards
CLI.
from the Terraform wise itself, from the IaC itself, we need to manage. Then we Terraform, our Terraform doesn't know those resource blocks. That's the reason we need to import those resources. So to which already those are existing in the AWS, but we need to import it to our configuration files, and we need to import it to state file
State
also.
file.
Whereas refresh is the reverse case that already resource is existing, but some manual changes has been performed out of our Terraform through the GUI or CLI. Okay, then I want to manage that. Say suppose my manager said, our client said, now like today onwards, we need to manage these through Terraform itself. Don't manage them manually. Okay, then I need to import those resources. Then can you tell me the use case for data source? What is the use case for
Uh,
the data source?
Data source, if it is out of our Terraform
Yeah,
and
that resource we
reuse.
don't want to manage. Say suppose some other say we have a shared VPC kind of thing. That is not only for our project. Say three different projects also they are going to use. Then another project A team is using Terraform. Like our GUI, they created the VPC. But I need to use that VPC. I need to create subnets, all resources. In that VPC only. Again, I don't want to create a new VPC, but subnets that said to create our security groups, all those, that's not in our state file. Then we don't know how to manage them. That is the purpose. We are going to use the data source block. And second use case is dynamically also some values I want to retrieve, like maybe AMI kind of things. There also I'm going to specify because otherwise, if I change the region each and every time, I need to change my AMI values. Okay, so for these two use cases, mostly we are using the data source, and the data source specifications also has been given by all that how to declare all the data sources. Everything is getting in the Terraform documentation itself for us. That means Terraform is creating how to use those data sources, how to use those like resources. They're giving the specifications for us, and using that we are going to work on those. But there is a slight difference between resource keyword if you use, data keyword if you use, and Terraform refresh, import, and data source also. We have the 3 different use cases to perform this. Okay, so now another very, very important scenario is, say here we have the provider, right? With the same name, there is a confusing word also is there called as provisioner. But don't get confused. Say, we need to explain the differences between provider and provisioner. So provider is a straightforward a driver kind of thing, and which is going to create the resources, data source specifications, all those we are getting, and using that provider we can have the declarative updates, and from that scripts like using HCL we are going to create the resources. Then the provisioner is like what is the provisioner is like a provisioner comes after resource provisioning, it comes into the picture. Okay, so I'll tell a use case. I created an EC2 instance. Okay, after this, I want to perform some automation. So already we discussed, right? We can use a configuration management solution like Ansible, Chef, or Puppet, but I don't want to use that. I want to use a Terraform itself for that also. Then that provisioner will comes into the picture. The provisioners are the final steps. You want to do some automation. For that purpose, we are going to use provisioners. Like mostly like in the AWS, everyone need to remember these provisioner names. We have the 3 provisioners we have. First one is local exec, then remote exec, then file is the 3 provisioners we have. So what are these? I'll explain. Say file provisioner will copy the file. Say suppose I have an automation script, Python script, that new resources doesn't know the script, but that is in my local Terraform where I'm running. Then file provisioner will copy that file to 100 resources which I have created. So what is the file is doing? In those 100 missions, it is copying that whatever the files or directories you want to copy. Then can you tell me if I want to execute that script on the remote missions, I need to use the provisioner local exec or remote exec? Which provisioner I need to use if I want to execute that script?
Remote EXE.
Remote exec. If I want to execute one command, if I want to execute any command on the remote missions, if I want to execute any command, what I need to use?
remote EXE.
Remote exec itself. Perfect. Okay. In my local Terraform, I want to run some scripts after instance has been provisioned. I want to send an email kind of things. That means that locally need to execute after instance provisioner. The provisioner will execute after instance provisioning only. It won't execute before. Okay. So then among these 3, which one having more benefit for us? Among these 3, which one having more benefit?
Remote EXE.
Remote exec, because we want to execute on the 100 missions. Then I have one solution not from Terraform in the AWS EC2. In order to execute the scripts, AWS having one solution. Any idea?
User data.
User data. That means instead of using Terraform, Terraform wise the solution is provisioner, or if you are using cloud, we have a cloud native support called as user data. In Azure also we have the user data or custom data we can use. That's also the best practice, or we can use like these provisioners. So can you tell me what are the provisioners here we have? What are the 3 provisioners we have? These all the names are very, very important on the interview wise. Local exec, remote exec, then file provisioner. File is to copy the files to the remote servers. It's not only one server, we may have 100 servers also. Then remote exec will execute those scripts. Local exec, after instance provisioning, I want to send some automation or I want to collect some information. After provisioning only I want to perform from my local mission, then locally exec will do. Then if I want to copy, say suppose even I created that instance, I may be not the owner of that. but I can't execute those remote exec or I can't copy the files. Then here we required connectors. Means those 100 missions created also, if it is a Linux mission, we required a connection type SSH, that the password or PEM file, definitely we need to provide. If it is a Windows WinRM kind of connection is required. So among those three provisioners we have, right? One provisioner not required those connector. Can you tell me which provisioner?
Local EXE.
Local EXEC. Local EXEC doesn't require that because that's executing on the local machine only. But remote missions to copy the files or to execute the scripts, it's mandatory. Even we are provisioning the instances. Assume we are not the owners of those. Okay. So bank loan the money and the bank employees can they use? It's not the banker's money, right?
Yes, sir.
Okay. In the same way, those instances we don't have all the permissions. Definitely we require the connection. So we have two types of connections are there. In which use case you'll use WinRM, in which use case you'll use SSH.
SSH for Linux or
SSH
Unix
for
man.
Linux and WinRM for
Windows.
Windows devices. Okay. On that, say for the local EXEC is not required, but for the remote EXEC and file, definitely we require those connectors. Okay. So either password or PEM key both are supported. But in AWS anyhow, we don't have the password, right? Okay. Then here, like a provisioner versus provider is also one of the very, very important FAQ. Has the names both are with the same kind of PP, it's the right provider, provisioner, same kind of understanding and confusion. That is the reason it become very big FAQ. Okay, so both you should able to explain very confidently. Okay, then we have the three types of provisioners and two types of connectors we have. Okay, any doubts on this? Then here one more related to this itself called as null resource. I want to execute one local EXEC for my automation, but for that purpose, I don't want to use a resource need to be created only for local execution. Then I can use the resource called as a null resource I can use. So null resource is one of the keyword kind of thing. In order to perform a local EXEC, unnecessarily creating an instance is again a budget for us or not?
Yeah.
Okay, then in that use case, I want to use local EXEC. At that moment, I'm going to keep that one in the null resource block. Then again, I no need to create
New resource.
a new resource is no need to create. A new resource is no need to create. Okay, so that is the purpose we are going to use
Null resource.
null resource is required. The null resource also is the mandatory interview question. Null resource also is one of the mandatory interview question. Okay, so after this null resource, it's mandatory. Like we need to finally need to come to like here we have a count and for each also. So what is the difference between count and for each also? We need to explain and like modules, workspaces, and resource implicit and explicit dependencies. That there here we have that depends on. Okay, then we have nowadays people are asking life cycle rules. Okay, so then finally we have some of the Terra Grunt kind of policies, all those also we need to work. Okay, so these all like we'll have the meta arguments, modules, workspaces, then we have the life cycle kind of policies. Then even we can have the Terraform policies can be enforced. and even we can use a scanning kind of thing, dry run. So those also we need to perform. Those all we'll discuss in the next session. So this week focus more on those videos, try to finish and perform the lab like a basic Terraform scripts resources from the configuration file. Try to copy different resources and try to provision them. After provisioning, clean up them and try to configure one remote backend also. Okay, so till this, try to configure this. Okay, any doubts?
No, sir.